What I'm going to talk about in the next 45 minutes here is effective lube storage. Because if you do all those things they talked about Monday and you don't receive your lubricants, get them stored in the proper way, get them stored in the proper conditions, all those things you do with the clean containers, it's not going to gain you anything, right? If you leave those barrels sit out in the rain, you leave those barrels covered with dust. I've been in gypsum plants where I went into their lube storage area and there was 4 inches of gypsum dust on top of the drums. And the maintenance guy walked in and took his finger and cleaned around the bung hole, pulled the cap off and stuck his pump in, and he filled up his container and took off to the plant. Now that plant, the majority of the equipment had a mean time between failure of about 6 months. Everything was failing, including big, expensive, multi-million-dollar gearboxes. So we're going to talk about how the best way is to store the lubes and take care of the lubes that you get in. So I'm an RCM facilitator. I do predictive and proactive maintenance. I do lubrication audits where I go into plants and help plants look at those failure modes they talked about Monday at the workshop. You know, the things you're doing in lubrication, but not only that, I help people consolidate their lubes. I go into plants and, you know, I was at a plant in Baltimore just a few months ago and they had 26 different lubricants at the plant. So we looked at all those lubricants. I taught them about the additive packages that were in there. You know, a lot of a lot of your EP lubricants. They had EP lubricants and AW lubricants. Well, finding out, looking at the specs and the oil analysis on those, it was the same additive package for the EP and the AW oils. So we just went to one. They both had phosphorus in there. The AW lubes, their anti-wear lube had about 3,000 parts per million of anti-wear. And some of the EP additives in our EPs were down around 400, but you can cross over things like that. Your R&O oils you can cross over from different vendors. So we got them all the way down to 10 lubricants, and then we were able to design their lubrication storage room and save them a lot of those errors you have when you have too many lubricants at your plants. But the plug-and-play lube storage rooms, we'll talk about that as we go through and some of the other things I do in the company. So you guys have seen a couple versions of the PF curve. This is my version that I use for training, where I split the PF curve up a little bit over this reactive area where we find out we're having failures by somebody coming in and telling us, or we're going out and touching things or hearing things. There's been a couple questions even in the last presentation about these different predictive technologies, which ones you use, which one's the best one, and you really don't know until you know what failure mode you're looking for. You have to understand what you're trying to find and then pick the right technology for that, the most effective technology that'll find that. Now what I do in my training, when I train on predictive technologies, you know, mechanical ultrasound finds more failures than any other technology that you can have. Now sometimes when you find that failure, you may need another technology to back it up to tell you exactly what the failure is going to be, but you can find the failure, the initial failure, with the mechanical ultrasound tool a lot faster. And then we get into this proactive area of the curve. These are all the things you do proactively. This is one of the things we find plants, you know, they're doing some of these things. Well, now the equipment's running good. It's doing what it's supposed to do. So what are we doing then? And one of those key things on here is lubrication excellence. You know, we're going to try to do processes and things to make the equipment last forever. So if we lubricate it effectively with a clean lube that has no particles in it, or particles below the film thickness between the bearing or a gear, which is 5 microns, if we take all the particles out down to 5 microns, you never have any wear in the component. So that's what we try to do with lubrication excellence. Precision alignment, precision balance. You know, Chuck talked about aligning things perfectly. If we do that process, you take away those failure modes of the bearings and different vibrations and things that cause your equipment to fail. If we balance our equipment correctly to low balance standards, I think Tim talked about that a little bit in his presentation this morning, you know, having select suppliers. Buy in motors with balanced rotors in them, buying pumps with balanced impellers in them. And then you have all these other things we can do in this area to become proactive and become very effective and efficient in maintenance. And as we do that, you can see what your dollar cost. If you're in the reactive area, your dollar cost is going to be a lot higher, and sometimes 5 to 10 times higher. So let's talk about main lubricant failure modes. They talked about this a little bit Monday in the lubrication training, but these are the 5 failure modes, the main failure modes I talk about when I talk about lubricants. You know, lubricants fail based on the temperature you run them at. And one of the charts I do in my lubrication training, for every 20-degree rise in that lubricant temperature above 70 degrees, you cut the life of that lubricant in half. So if you take any mineral-based oil and you can keep it at 70 degrees in your plant, it'll last for 30 years before it oxidizes. If you're running it at 90 degrees, it's only going to last 15 years. If you're running at 110 degrees, it's only going to last 7.5 years before it oxidizes. And that's if we keep all the water and the particulates out of it. So you got temperature failure modes. Then you have moisture failure modes in lubricants. So if we have moisture in our lubricants, whether the moisture is coming in new in the lubricant, or it's coming in from your process, or it's coming in from the ambient conditions, that's going to make the oil oxidize a lot faster and it's going to fail, and it's not a lubricant anymore once it oxidizes. I mean, me and Gary talked about this yesterday on a car. You know, so you go to your car, you know, when do you change the oil in your car? Well, Gary said his manufacturer said 13,000 miles or something like that. You know, my wife got her car, she said it's 8,000 miles. I don't have to change my oil for 8,000 miles. I said, no, we'll change it when the oil changes color. That's when I change it in my vehicle. So as soon as it gets dark, it's oxidized, and now it becomes something other than a lubricant once the darker it gets, and the more change it goes through. But moisture causes some of that oxidation. Then if we have 4 material particles in that oil, that's a failure mode, right? Now, how many of you think when you buy a brand new drum of oil that it's clean? It's not. One of the things I do in my lubrication audit, I go around and I pull samples out of the new drums. And I have levels that I want that ISO code to be at. They're never there in a new drum. They're never where they need to be in your plant to get those 3 and 10 times life out of your equipment. The lubes are always dirty. So as the new lubes come in, we need to filter those particles out. Then you have viscosity failures, and this is one of the things, a good reason to test your new oils once in a while. I've found drums of oil on lube audits that says ISO 220 on the drum, and the sample comes back and says it's ISO 150. Now, if your maintenance person doesn't catch that, what happens? You could have failures, right? I was at an Owens Corning roofing plant, and they were showing me their oil analysis on the gearboxes on their line, and every one of the gearboxes in their information said it's supposed to be ISO 220. Every one of the oil analysis came back ISO 150. How's that happen? We went to their storage area, and that's what was in the ISO 200 drum. Somebody had pumped 150 in there as they filled the drum. So that's another reason you do those samples and check to see what you have and have a good system to control those. These failure modes you see here, I do a training course called the 100 Failure Modes of Lubrication and Lubrication Programs. These one that I italicized here are failure modes that you have control of just with storage. You know, no procedures for ordering, no procedures for receiving and testing, no procedures for storing the lubes, improper, no, you know, online or offline filtration when you bring yours in. This one right here, additive package depletion. I've tested oils in plants that were supposed to have additives in there, and they're not in the drum. Noria has told me that they've tested drums of oil that came to a plant that were all additives, 2 in the last 5 years. What happens to your equipment if you put all additives into a gearbox or a pump?
Well, you can just use crude oil after that, can't you?
Yeah, well, additives aren't lubricants. They're chemical compounds. So if you put all additives in one of those components, it's going to fail because it's not a lubricant. You know, no best practice lube storage rooms. No lube consolidation programs, they haven't done that step. No filtration training. You know, I see people all the time, they buy the filter cards. And I say, what size filter do you have on there? Well, whatever they sent me. So what are you filtering to? What are you trying to filter out? What is your lubrication excellence program? What are you trying to get down to? What's the smallest particle you want in your equipment? You have to be able to answer those questions, then you buy the filter for that. You know, no process to take the moisture out like we just talked about. There's filters that will do that. Here's the foreign material, contaminated new oil. Your new oil coming in is dirty. Improper filtration or no filtration of new lubes. You know, poor lubrication storage methods, poor lubrication equipment storage. Now, not only do you store your lubes in these lubrication rooms, I'm going to talk about this effective lube storage, but that's where you want your grease guns. That's where you want your oil-safe containers. That's where you want your spare filters. And if you're using funnels, which I don't recommend, but that's where you want your filters. You want it in this clean room. I remember my guys at the plant, they would bring their grease guns in at the end of the day, and they put the grease guns in a big Ziploc bag, and then we put the Ziploc bag in the cabinet. We didn't want any particles on our grease guns. You know, these moisture control things, ambient conditions, humidity, and rain. I've seen drums, and I'll show you a few pictures of storage areas that are outside under a lean-to 100 feet from a coal pile. I've been in aluminum foundries where the drums are mounted on a rack on the wall, and there's nothing in the vent hole. And it's in a foundry, and everything's covered with dust. Additive depletion. How many of you here store your drums on a concrete floor? You know, if you store a steel drum on a concrete floor, the limestone in the concrete creates a charge in the drum, and it pulls all the additives to the bottom of the drum. So what happens now if you're using the pump and you go stick that in there? What do you get when you first start taking the oil out of the drum? You get all additives. What do you get at the end? No additives. So they have to be stored on a wood pallet. They have to be stored on something, a plastic pallet. They can't be stored on a concrete floor. So your lubrication storage methods, your lube equipment storage methods, again, back on the moisture. So many of these failures we have in our plant with our lubricants start with the way we store the lube and we take care of the lube after it's received at the plant. Here's a plant where they didn't have a place to do it. We did put covers on top of the drums to keep the moisture and stuff off the top of the drum. This was all they had at the time. Now, since they've installed a lube room. At this plant here, I went back in the back of these drums, and there was a drum back there labeled 2000. This was about 6 or 8 months ago. And I crawled back through, and the drum has a date of 2000 on it. It had been back there for 8 or 9 years. The guy says, "What should I do with it?" I said, "You got to throw it away." I said, "The additives are probably gone. There's probably moisture in there, and no telling what. There's probably rust in there, right?" I said, "Just dispose of it." So what do we need? You know, your lube products protected from the environment, your plant dirt, the FM that's around, the moisture and the sunlight. You know, don't let the drums sit out in the sunlight, get hot during the day, and then get a little bit of rain and cool off at night. Even though that drum's never been opened and sealed, it'll pull moisture into the drum. Filtering your plant lubes. Filter new lubes or lubes as you use them. There's a couple ways to do this. I'm building a unit for Canada right now where they're going to put the drums in this storage room, and they're going to put a filtration system on the drum. So when they start the drum up, it's one of these deals where the tube goes down the bottom, and then you can recycle through the filter and right back in the drum, so you can filter the drum, and then we put a little spigot on there, so the maintenance guy goes in and starts the filtration system up, and then he gets his lube as the lube's filtering the drum, so they're filtering as they use it out of the drum. Another method to make sure you get all the particles out. Storing your containers, your grease guns, keep it separate from other plant chemicals and products. A lot of failures in plants, and one at the plant that I came from, because other things were stored in the lube room. And somebody not paying attention picked up the wrong product, and we had a failure. Controlled environment. I just on the phone this morning, I left the meeting, and a guy calls me from a gravel pit. They want me to build him a lube room and send it to him. And I'm asking about what he wants in it. We're talking about the size of the tank, the size of the filters, the size of the pumps. I told him I'm going to insulate the inside of the container. And I says, do you want an air conditioner in it or a heater? What do I need the air conditioner for? I said, well, you're going to have a steel shipping container setting in the sunlight, and in the summertime, it's going to get up to 120 degrees in there, and your guys are going to open the doors to go in there to get something out of it, and it's going to be hot, so they're going to leave the doors open. You know, particles are going to come in, plus the lube's going to get hot and cold, right, over summer and winter. Their desiccant breathers may not last very long. So these areas where you store your lubes should be some kind of control of temperature and some kind of control of humidity. A lot of them, I build, we put dehumidifiers in them because they're in Louisiana and Texas where you have high humidity conditions. Your products are labeled and visible. It's a clean air to store your lube equipment. You know, your products can be circulated to mix the additive packages. Now, I don't build many lube rooms for Cargill, but I know if I build a lube room for Cargill, the standard is you would recirculate the lube in the container, every month, Tim? And one of the reasons to do that is because eventually, the longer you store those lubricants, that additive package will still settle. Some of the additives, not all of them, but some of them will settle to the bottom, and we need to remix those additives back in the lube. It's better inventory control, it's safe lube storage, it's free from fire sources. I get this one all the time. I said, my safety department tells me that the lube room has to be explosion proof. I want explosion proof lights in the lube room. And I said, well, if you want explosion proof lights, do you want an explosion proof air conditioner? Do you want an explosion proof heater? Do you want explosion proof plugs on all the pumps? Well, yeah, I guess I have to, right? No, you don't have to, because a lubricant is called a Class 3B fluid. And Class 3B fluids are any fluid that'll vaporize above 200 degrees. Well, if you look at your lubricant information, lubricants don't flash until they're at 475 to 525. So you have to have a damn big fire around that container to get it to make a vapor, so it doesn't have to be explosion proof. But I build explosion proof lubrication rooms for people. Now, the difference in cost is the air conditioner I stick in a standard unit is $600. The air conditioner you stick in an explosion proof unit is $3,500. And that's for Class 2 Division 2. If you want Class 1 Division 1, it's $8,500. Now, I'll put anything in there you want. It just costs more, right? But you really don't need it. I put sprinkler systems in all of them, and some of them I put a dry chemical release system, but they really don't have to be explosion proof. They do not give off vapors. And I've shown this to people at plants. You take a 5-gallon bucket, put a couple gallons of lubricant in it, and take an acetylene torch and stick it in the 5-gallon bucket. What's going to happen? It'll eventually get hot enough and it'll start burning, right? But what happens when you take the torch away? The fire goes out. So you have to have a lot of heat. So the whole room's going to be on fire before you can get the lube to burn. So lubricants are not unsafe to store. Here's a storage area to plant. And you can see here they've got the drum setting out in the open. They've got their funnel sticking on top. They've got their containers on top of the drums right in the open area. This is diatomaceous earth and filter aid right behind it. Abrasive? Better believe it. So we've got to take steps to eliminate storage, designated areas, develop written procedures. How the lubes are received, how they're stored, how long it takes them to get them inside, how we're going to store these barrels and containers. So lube storage, it's a must for any plant that's moving to lubrication excellence. But just like I said, don't buy the oil-safe containers and go to all those steps where you're taking the lube around without first taking care of the lubes and storing them correctly. Remember these pointers. The new lubes aren't clean. All your lubes must be clean and dry. They must be stored in this controlled environment, and your lubrication equipment have to be clean. Here's a chart here. We talked about that 5-micron film thickness on a loaded bearing or loaded gear. So how big do those particles have to be to cause us problems or cause wear? Well, if you go to your house or you go to that door frame up there and you run your fingers across there, that fine floor dust you get on your finger, those are 40-micron particles. So those are boulders when you put them into a bearing or a gear, right? That's what starts that microscopic damage in the component. So you can see here the particles we're trying to take out are particles down around 5 or 10 microns, the size of a red blood cell. Those are the particles you want to keep out of your lubes. Then you can see all this dust, 40 to 50 micron and all these other things up here in these particles. Here's a slide that comes from Caterpillar. Caterpillar's huge in oil filtration. They have to be for where their equipment runs, right? In mines and in the desert. This is the diameter of a human hair. And these are the particles they do in their training. They're trying to take out of their lubricants to keep their components running longer. The trucking industry is another example. In 1984, the trucking industry, about every 250,000 miles, you would pull the engine out and put a rebuilt engine in because the engine was basically worn out. Well, through work that Noria did and other companies, you know what truck engines get on today? Over 1 million miles. I stopped at a place the other day and there was a truck engine there. It was at 1.4 million miles. And the way they do that is one of the things is synthetic lubes, but they also filter out all the particles. There's nothing left in there to wear out the engine. The same thing we can do with our equipment, right? This picture's kind of dark. This picture was taken at a coal plant. I mean, it looks like a good storage system, right? All the tanks are in there. They're all labeled. They got some of their equipment down here, an open container. But like I said, this is a coal plant, coal power plant. The vents up here on top are just little bug screens. They're steel tanks. They've been in this room for about 27 years. The oil is dumped in from the next floor up and just flows down into the tank, but pretty dirty. When I looked in this container right here, a lot of particles in there. Looks like a good system, but wasn't very clean in there. Here's another, the other plant we looked at. Here's another storage area they had in that plant. All the containers sitting outside in the plant process area, all these containers on top. And for some reason these slides are a little darker, but this is a picture of another storage. This was the maintenance shop in this plant. These are bags of diatomaceous earth and clay and all kinds of filter aid that they're using in an oil refinery. And look at the dust on top of the drums here. That's their lube storage area. Look at these containers right here that the guys are coming in and taking their products around the plant. Now this one you can't see very clear, but there's particles in the bottom of that container. And I stood up on the steps and watched the guy come in and fill this container up and take off out to the plant to put that oil in a piece of equipment. I wiped off the top. This is what was in the bottom of that container. Now remember, you can't see particles. The human eye can't see particles smaller than 40 microns. So how big are those particles? They're huge, yeah. And what if we put those in a gearbox or a pump or a bearing? What's going to happen to it? You're going to wear it out. This was a plant I went to. They had these expellers. An expeller is about a $250,000 to $400,000 press that presses the oil out of oil seeds. And this was their oil for the expeller, sitting on top of a cabinet in the press area, and that's a funnel sitting there that they use to put the oil in the expeller. Now, how clean do you think that funnel is in an oil processing plant? It was covered with dust particles on the outside and the inside, but they're going to add that oil to the piece of equipment. Here's an oil storage area. You know, a lot of stuff in there besides oil containers, right? The used oil's in there, the mop bucket's in there. Not a very effective storage area. This is a slide I used when I was training the guys at the plant I came from. We pulled a sample out of a gearbox on a coal system where the oil had just been changed a month before. I had them go up and pull a sample. And I had them bring the sample down. At the end of the day, all 10 of my maintenance guys, we all looked at the sample. You couldn't see anything in the sample. I said, what do you think of the oil? It's good. I sent it to Insight Services. This is the picture that came back. It was a 22-19-17. This was what was in the oil. Just like Tim said, this is new oil you're getting in, and we were getting oil in, brand new oil, and it was in that 21-19 range. This is what was in there looking at it under a 100-power microscope. We went up there and filtered that oil with a 10-micron Beta 200 filter for 4 minutes. We sent the oil sample back, and this is what comes back. How much longer does my gearbox last? A lot longer, right? I mean, there's particles of fly ash, there's rust, there's all kinds of things in that sample. This is a chart here for hydraulic oils. We look at this 22-19-17 oil, the oil we have in there. If we filter that down to a 10-micron Beta 1000 filter, 5 times the life on that hydraulic system taking those particles out. Here's a moisture extension chart. Let's say you have 1,000 parts per million of moisture in your oil, and we can get that down with filtration down to 50, 6 times the life just taking the moisture out. I was at a plant in an Invista plant in Orange, Texas. We were doing an RCM on a big gearbox, and they said the gearbox, it was the same ones we used at Cargo, big 600 horsepower gearbox. They said the gearbox, they had to change it out every 8 months because the mean time between failure was 10 months. I said, we use a bunch of these gearboxes. I don't understand that. Well, when I looked at their oil analysis was 40,000 parts per million of moisture in the oil. And the reason that was happening is because water was running down the shaft of this piece of equipment all over the top of the gearbox, and water was getting in the gear reducer. So I walked out there, looked at it. There was a nitrogen line about 20 feet away from there. I said, run the nitrogen over here and let's put nitrogen, pressurize the top of the box with a couple inches of nitrogen so the water can't get in. And the other thing, the nitrogen, by flowing the nitrogen across the top of the oil, the moisture levels came down in the oil because they were absorbed by the nitrogen. We'd vented it off. And this is what happened here. If we reduce this down from here down to 1,000, look, 9 times the life. That was about our mean time between failure at Cargill plants with that same style gearbox was about 8 or 9 years. It was all related to moisture. Here's bearing life extension. We cleaned the oil up. 22-19-17. Filter it down to 10 microns, 3 times the life. And we can keep filtering down and taking these particles out. You can see what happens to the life. So lube storage fundamentals. Develop procedures to get your products filtered and stored. Develop filtration standards. And this is one of the things, you know, I go around to plants all the time and they'll have filter carts and I'll say, what size is the filter? What's the beta rating on it? Oh, I don't know. I bought it from Desk Case or I bought it from somebody else. They have no idea what the filters are actually doing. Design an area away from the FM and the moisture and contaminants. Keep your lube equipment in there away from those particles. Here's a lube storage building that a company built inside of a warehouse. I think they spent about $60,000 for this, an insulated metal building inside of a warehouse. This is the inside of that building. Here's their lube containers, desiccant breathers in all the containers. The room is heated and air conditioned. They've got nice clean shelves here for all their equipment. Here's a lube storage area a company put in. Steel tanks. I don't prefer steel tanks, but some companies prefer steel tanks due to the fire. But, you know, and I build lube rooms with these in there, but every time I put them together, you know, you run your hand inside the steel tank, and there's rust and particles in that steel tank. So now you got to circulate that tank and get that stuff filtered out. And do you ever get it all out? I don't know. And here they didn't put any desiccant breathers on the tanks. Here's an outside storage area where we put some desiccant breathers on there. I came back 6 months later. The reason I took this picture is because these desiccant breathers are supposed to be blue. And then they turn to red when they're saturated, right? And then when they're completely shot, they turn white. So they've never changed the breathers. They absorb the moisture, they never change it. I was at a plant one time where they were using the Air Sentry ones, the gold ones. And they had been on there so long, there was mold growing on the inside in the desiccant. You have to change them. Here's a lube storage area at a plant. They don't have the desiccant breathers on here yet, but a nice clean room with some spill control. This unit here, I built this unit. I started building these in shipping containers and sending them to customers. And the whole idea of this is when I go around to plants, we design rooms. A lot of times plants don't have a space to build a lube room. Production's not going to give up any space to you. A lot of times maintenance don't have space to give up. And then a lot of times when you start getting building permits at plants, you bring the fire guy in to put a fire line in. You bring the electrical guy in to run the electrical. You put spill control in some part of your plant. The cost of this one here for them to do it at that plant was $60,000 when he came back. And we built this room here for $32,000. It's just a shipping container. It's insulated. He's got 10 tanks in here. He's got 10 pumps. Each filter or each lube has two 10 micron beta 1000 filters on there. So he's taken 99.9% of his particles out on the first filter and then taking the rest of it out. And then the maintenance guys go into this air-conditioned room and they get their lubes out of here. Now, what you were asking before, if you got moisture, you can take one of these cartridges off and put a moisture absorbing cartridge on there. So you can take particles and moisture out. This lube room here is in a salt mine 1,800 feet under Lake Erie. And what they do here, they bring their lubes in, they filter them through these 10 micron beta 1000 filters, they store them in some different size tanks. These tanks have air pumps on them and they keep these hose reels pressurized. So the mine truck, I don't have a picture of it, the mine truck just pulls up outside and gets whatever lube they want without ever going in the lube room. So they're getting nice clean lubes. And you see this one here, it doesn't have an air conditioner or a heater because the temperature never changes in the mine. It's always, what, around 70 degrees. Guys are working down there in shirt sleeves, and so they don't need air conditioning. But a nice, clean storage area. Here's a lube storage cabinet where they got their containers in a cabinet. They got their grease cartridges stored on in. How do you guys store your grease cartridges? The manufacturer will tell you to store them on in, right? Is that the right way to store them? It is if you don't have ambient controls. Because if you store them on their side in your plant and it gets up to 100 degrees or 105 degrees, what starts happening? Yeah, the oil starts running out of the cartridge, right? You store that grease cartridge on its side in a room that's 70 or 72, the oil doesn't come out. And it's evenly distributed through the soap or the binder, right? You store them on in like that and it does separate. It's the same thing that happens in your drum. Now you got more oil in the bottom or more oil in the top of that cartridge, so you don't get even distribution of your oil using your grease. But put them in ambient controlled conditions and the oil stays concentrated through the soap and binder. This one here may look pretty rough, but I went to this gold mine in Nevada and they had all these totes sitting in a lean-to outside. And the mine trucks pulled up and the guy went up there and he had a pump and he was putting his fluids in the mine trucks with mine equipment out here. We bought a 40-foot shipping container and we cut, whoops, I keep hitting that button. And we put garage doors in there and we got these containers inside, out of the weather, out of the sun, so they weren't exposed to the elements anymore. And then down at the end we put some hose reels and air pumps down here, so now the mine truck can pull up and get whatever lubes he wants in the mine truck. So the units are stored inside, we do some filtration on the oils, and like I say, it looks pretty rough, but when you go to these mines, I mean, they're in the middle of nowhere and they don't have many resources. So this here got a lot of particles out of their lubes with the way the guys were handling the lubes. You know, J.M. Smucker in Tennessee, you know, they did the lubrication excellence about 5 or 6 years ago at just a food plant. And they started, I think when we started there and did the whole reliability training program and did the lube stuff there, they were having like 120 failures a month on their lines. And after 3 years, Billy told me they were down to 6 failures, you know, of bearings and different equipment on their line, just because of all the, and it wasn't just lubrication, it was a whole full-blown reliability program. So a huge success story there. So case study, you know, need to reduce failures, develop written procedures, train everyone in lubrication excellence, and then develop this area. You know, find an area in your plant, a clean room, buy the right equipment, buy the right filtration, and have the procedures for that. Here's the lube room at the JM Smucker plant in Memphis, Tennessee. 20-foot shipping container, painted white on the outside for the food plant, the guards. And here they don't take any drums inside the room. They have a fitting on the outside. The drums are brought outside. They hook onto the lance and pump the drums into the room. And here's their filtration. They got a water filter. They were having water issues with their lubes coming in. So they've got a water filter and a particle filter, a 3-micron particle filter. Now they started off at 10 microns, they went to 5 microns, and now they're down to 3 microns, and they call and say, we want to go to 1 micron. Well, you know, you don't need to go to 1 micron. You know, you get down to 5 or 3, and that's really as low as you need to go with this type of equipment. Here's their manifold labeled with the different oils to their tanks. Here's some Rhino Tough tanks we installed in some systems, but you can see these are nice, easy systems to build. So, and this is something you can do yourself. You can buy a shipping container, you can insulate it and stick all your stuff in it and put an air conditioner in it. Here's their oil safe container stored in a cabinet. New ones, this is when it came to them new, so they have a stainless steel workbench in there for the guys to fill the grease guns, but all their lubricants are kept in nice, clean areas. And this is some pictures they took there tonight. They're really proud of what they're doing there with their equipment and how clean they're keeping their lubes. These are some cabinets they stuck out on the floor to store some of the lubes. That's a good ways away from the maintenance shop, but everything's in a nice fire cabinet here. So designing of your lube and storage room, you know, you want to filter and store all your plant lubes. You want to make it large enough for your lubes and all your lube products. So that's when you get down to looking at all the lubricants you're actually using, try to consolidate them. You know, just use the ones you need to use there. A lot of times you can do that by going to synthetics because they cover a wider range of temperature and application. Ambient control, you know, heat, AC, so you're just trying to maintain that consistent temperature. You know, spill control is real important. I'm building one now for California. I mean, the whole floor is going to be graded in spill control because the rules, and you know how it is in California, the rules are different out there for everything you do. Humidity control. There's areas of the country like in Louisiana and Texas where the air conditioner is not enough to reduce the humidity in there, so we put dehumidifiers in there. You may have to look at that. Storage for your lube application equipment, we talked about that. We talked about this fire protection thing, what lubricants actually are. So do you need it or don't you need it? Now I stick a sprinkler line in every one of mine. You can hook it up or not hook it up, and about 50% of the people hook them up, the other ones don't. But it kind of depends on where you put the container, right? Where there's really going to be a fire hazard if you get a fire around it. Access to maintenance personnel. You know, that's the only people you really want in there, right, is the lube tech or the maintenance people. And most of the ones I put on now have combination locks on the doors. So if somebody gets the combination, you can change it. The filtration, you know, keep your filters in there. So that's my, my session on effective lube storage, how important it is to your process, to the longevity of your equipment. But you saw some of the charts there, how much longer your equipment's going to last if you take care of the lubes, right? So if you have this storage area, then you do all the things that Allied talked about Monday as far as getting those lubes around to the plant, cleaning the grease zerks off, using the right equipment, and then follow their 5 rules, you know, the right amount, the right time, and those things there, you'll start seeing longer equipment lives. But one thing I always tell people when you do lubrication excellence training, if you start doing lubrication excellence today, well, all your failures go away. Why? Yeah, that stuff's out there is really worn out, all right? But as you put in new equipment, as you put in new gearboxes and new bearings and you put in new pumps, those equipment life cycles are going to go up to that 3 to 10 times more life because now we have no particles in there to wear out the components. All right?
Any questions?
Oil that is stored in a drum, what period? Oil that is stored in the drum, what period of time
can it sit in that drum?
Well, it depends on where you have it stored. If it's real
It's
hot.
atmosphere controlled.
Oh, it's atmosphere controlled?
Yeah.
Well, like I said, if you keep it at 30, or you keep it at 70 degrees and you keep the moisture away from it, that oil could last for 30 years. Now, if there's moisture in there,
Well,
you're
I
going
was
to...
worried about the additives settling out.
Now, the additives are going to settle no matter what. They'll settle a lot faster if it's on concrete, but they're going to settle in that drum. So you have to have a way to mix it up. Now, I've seen guys lay the drum on the floor, you know, and roll it across the floor a few times to mix it up, but you know, Descase makes a nice little deal. You screw in the top of the drum with the long pipe that goes to the bottom, and then you can just recirc the drum.
Do they have little agitators?
Or you can put the little agitators on them and mix them up, but the additives will settle over time. You know, one or 2 months.
What kind of time we talking about? I guess that's the
A
question.
couple months. 1 or 2 months, those additives will be on most of the additives will be on the bottom. Now, not all of them go down. Some of them stay in suspension because they're mixed, but a lot of your additives will go to the bottom.
So
And like I
after
say,
a month or two, you need to be mixing it up or recirculating it.
Yep.
What's your take on food grade lubrication versus non-food grade?
Well, if you'd asked me that 10 years ago, I would have said the food grade lubricants aren't worth a shit as a lubricant. But today there's better food grade lubricants. They got synthetic food grade lubricants, and they've got better food grade lubricants. They're still not as good, and they still don't last as long as a petroleum based, and definitely not as long as a synthetic based. But so, you know, whenever I go into a plant and they're doing lubrication, we're setting up lubrication routes and things like that. You have to do it more often because the lube will oxidize if it's running hot, or if it gets hot, and it will melt out a lot easier.
Anyone else?
Terry, what's your take on the biggest obstacle you have or companies will have implementing best lubrication practices such as you've described today?
Yeah, the biggest obstacle with lubrication is getting management to understand the importance of it. You know, maintenance people understand the importance of lubrication. They understand these failure curves, you know, with the particles and the moisture, but it's getting management to buy in on this. And a lot of times I'll quote a lube room and I won't hear back from anybody for a year because it takes that long because the guys want it and they know they need it, but it takes that long to get money approved for that. So it's kind of getting management buy-in. Now once you get companies like Cargill and JM Smucker and another one is Owens, some division of Owens Corning. They understand these principles now, so they got money, and the plants are really improving and reducing failures because they have that financial and leadership support.
Is there a financial argument you can help provide?
Yeah, well, basically, if you do this slide presentation here with you guys have it, showing them those charts that these particles actually cause failures. And I can send you more information on that. I mean, Maraine's got my contact information. I can send you more charts. I can send you more information that show how these particles reduce the life of your equipment, how the moisture reduces the life of your equipment, how all these new lubes are dirty. And that's an easy one to do if you got an oil analysis lab. You know, a lot of people do oil analysis. They check the oil that's in their equipment. Pull some samples of your new drums. And you'll find out right away, just like we found out at Cargill and other plants find out as we do these lube audits. So that lube is not clean. You'll get some down around 18, 16, 15, but I've never got anything below that on a new lube, unless it's a synthetic. I've found some synthetics that are much cleaner than that. But
Okay. All right, Terry, good information. Appreciate that. Good job.